Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation or an equation from solvable for y. So let's get going. Problem: solve y equals to 2px minus p square. Consider the given equation as equation 1. So here, observe the powers. Okay. If you take y, power of y is 1. So we can say that 1 is of first degree in y. Likewise, if you observe x, you have x power 1. And also 1 is of first degree in x. If you notice p, you are having p square and p power 1. So here 2 will be the degree of second degree. Equation 1 is of second degree in p, right? Since first thing, the equation we cannot factorize it. And second thing is 1 is of first degree in y. Give an equation I'll write here, okay? Of first degree in y. So we can solve 1 for y, okay? So we are going to use solvable for y. Also we can use solvable for x because it is also first degree in x, okay? But here I am going to show you using solvable for y method. Solution: given equation is y equals to 2px minus p square, right? Now differentiate 1 with respect to x, then d by dx of y equals to d by dx of 2px minus p square, then derivative of y with respect to x equals to derivative of first term with respect to x minus derivative of second term with respect to x, right? We know that dy by dx is p, right? Since dy by dx equals to p, then p equals to, we can take 2 outside the derivative, okay, minus, I wrote the same thing. Okay, now let's find derivative of px and p square with respect to x. This becomes p equals to 2 into, here we are going to use uv whole prime formula, which is equals to u dash v plus v dash u, right? Then we'll get derivative of p with respect to x into x plus derivative of x with respect to x into p minus derivative of p square with respect to x is 2p into dp by dx. Then above equation becomes p equals to 2 into derivative of p with respect to x is dp by dx into x plus derivative of x with respect to x is 1 into p minus 2p into dp by dx, right? Then p equals to 2 into x into dp by dx plus 1 into p is p minus 2p into dp by dx, right? Then p equals to 2x dp by dx plus 2 into p, 2p minus 2p into dp by dx. Now we can write this equation as, first I'll write the RHS part, 2x into dp by dx plus 2p minus 2p into dp by dx equals to LHS p, right? Now bring this p to LHS, we'll get 2x into dp by dx plus 2p minus 2p into dp by dx minus p equals to 0. Then 2x into dp by dx plus 2p minus p is p minus 2p into dp by dx equals to 0. Now take dp common from these two terms, then we'll get, firstly I'll write the two terms together, minus 2p dp by dx plus p equals to 0. Then 2x minus 2p into dp by dx plus p equals to 0. Now take this p to RHS, we'll get 2x minus 2p into dp by dx equals to minus p, right? Now in the next step we'll take the terms under brackets to RHS, then dp by dx will be equals to minus p by 2x minus 2p, right? Then dx by dp equals to minus of 2x minus 2p by p, right? Or we can write it as dx by dp equals to minus of 2x minus 2p by p. Then we'll get minus of, now split this fraction into two fractions. Since we are having two terms in the numerator and one term in the denominator, so we can split it as 2x by p minus 2p by p. Here p gets cancelled. Then dx by dp will be equals to minus 2x by p minus into minus plus 2, right? Now bring this term involving x to LHS, then we'll get dx by dp equals to, plus 2 into x by p, or I'll write 2x by p equals to 2, right? I can also write it as dx by dp plus 2 by p into x equals to 2, which is the linear equation in x, right? Now let's compare this with linear equation in x and p. Here just treat x as dependent variable and p as independent variable. Then we'll get, okay, then this will be the general linear equation where p and q are either functions of x or, either functions of p alone or constants. Okay. Where p equals to 2 by p and q equals to 2, right? So here we need to find integrating factor, which is given by e power integral p dp, okay? and the general solution will be given by dependent variable into integrating factor equals to integral q into integrating factor into dp plus c. Right? Fine. Now consider the linear equation as equation number 2 for our convenience. Now we need to find integrating factor. Before heading to integrating factor, let's find integral capital P into differential dp is equals to integral. We have capital P, which is 2 by small p into dp, right? This is equals to 2 into integral 1 by p dp. We know that integral 1 by p is log mod p. Then we can write it as log 2 log p, which is equals to log p square, since m log n is equals to log n power m, right? So therefore integral p dp equals to log p square. Now let's find integrating factor. If equals to e power integral p dp equals to e power, we have the value of integral p dp, which is log p square. Then e power log p square is p square, since e power log some function of p equals to function of p. Okay. Now we are going to use this formula. X into integrating factor equals to integral q into integrating factor into dp plus c. Then x into integrating factor, we are having p square equals to q. Q we have 2 into integrating factor p square into dp plus c. Now take the constant outside the integral, we'll get 2 integral p square dp plus c. This equals to 2 into p cube by 3 plus c. Or we can write this term as 2 by 3 into p cube. Okay. Now take this p square to RHS, we'll get x equals to 1 by p square into 2 by 3 into p cube plus c. From this we'll get x equals to 2 by 3 into 1 by p square into p cube is p cube by p square plus 1 by p square into c, or c into 1 by p square. So here 2 p's gets cancelled from the numerator and the denominator, so we'll get 1p plus c into 1 by p square, or x equals to 2p by 3 plus c by p square. Consider it as equation 3. Now we have to eliminate p from 3 and 1. Simply we'll replace x in equation 3 in 1. Okay. Substitute 3 in 1. Or eliminate p from 3 and 1. We have equation 1, which is y equals to 2px minus p square. Now I'll replace x by equation 3. Okay. Since x equals to 2p by 3 plus c by p square, then 1 becomes y equals to 2p x minus p square, for x equals to 2p by 3 plus c by p square. I'll consider it as equation 4. Or let's simplify this. Then y equals to 2p into 2p by 3. 2 2s are 4. 4p square by 3 plus 2pc by p square minus p square, which is equals to 4p square by 3 minus p square plus, here 1p gets cancelled, so you'll get 2c by p, which is equals to 4p square by 3 minus p square is 4p square minus 3p square by 3 plus 2c by p, right? 4p square minus 3p square is just p square, right? So from this we'll get p square by 3 plus 2c by p. Then y equals to p square by 3 plus 2c by p, considered as equation 4. So we have come to know that it is not possible to eliminate p from 3 and 1 and also from 4 and 3, right? Here, elimination of p from 1 and 3 is not possible. So the general solution or the required solution is given by x equals to some function of p and c, or the required solution will be x equals to function of p and c and y equals to some function of p and c. Okay. The required solution is x equals to equation 3, 2p by 3 plus c by p square, and y equals to equation 4, p square by 3 plus 2c by p, right? Where p is the parameter. This completes the problem. So we have seen a problem from solvable for y in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.